everyone. Again, on behalf of IIT Pune chapter, Buzz Engineering Academy and Civic Incubation Center, I welcome you all to the day 8 of our workshop on AI/ML for Internet of Things. In a world driven by innovation where artificial intelligence, machine learning, and Internet of Things have become the backbone of transformation, we have already embarked on this incredible learning journey, and over the next few days we will delve into all the fascinating things, unraveling the mysteries and exploring the boundless applications of our topic. And to do justice to our topic, we are having two guests today, who will be encouraging us and explaining us the concepts. Very first, we have with us uh, Dr. J. Ramesh Babu, who is currently working at Methodist College of Engineering and Technology, Hyderabad, Telangana. Sir has completed his BE from JNTU College of Engineering and his Masters in Engineering from University College of Engineering, Osmania University, and he has done his doctorate of philosophy. He's pursuing it currently from Biju Patnaik University of Technology, Odisha. I welcome you, sir, on behalf of IT Pune chapter and Buzz Engineering Academy. Now I request you to please come up on the virtual dais and take over the session.
Thank you, madam.
Yes, sir.
Thank you, sir.
Yes, sir.
Can you share my screen, sir?
Yeah, not yet, sir. Yeah, share it once again.
Not shared.
Not shared. Yeah. Yeah. I think your mobile is visible.
Yeah. It's open, sir.
Yeah. Yeah. WPS is there. Yeah. Yeah. Role of IT and AI battery management of electric vehicles. Yeah. Now okay.
Thank you.
Yeah. Go ahead, sir. Okay, sir.
So, good evening to all.
Yeah.
So, today I'm discussing about what is the role of IoT in AI battery management system for electric vehicle. So, nowadays all of you using in electric vehicles. I'm recently work also in electric vehicles, but here the major part of the electric vehicle is the battery management system is very important. My role is battery management system. So in our topic, how to battery management system by using IoT and AI techniques. Fundamental of that one. So a good battery give electric vehicles. So what is the electric vehicle actually? It is combination of battery. So here no discussion about of battery to vehicle. Battery to vehicle. So in battery means battery to vehicles means it will be more. So what happened? Battery is connected to the converter. The converter is connected to the motor. So here the converter means input of converter is DC supply. Output is depending on the motor. Depending on motor. Suppose the motor is BLDC motor, that is supply. So the converter using here DC to DC converters. And suppose the motor will be AC motor in traveling of the vehicle. AC motor means the converter using for DC to AC. So that is like as an inverter. So here nowadays all of you by using these electric vehicles. So here long traveling, it will be long traveling. Long traveling. The long traveling is very, very important. Okay. So means the health of battery good. The traveling is more long traveling. So, I mean, battery is energy density. The more energy density, battery is more energy density. The more energy density means the more capacity is available. So, distance will be no 200 kilometers or 300 kilometers, even the battery. So, the battery safety is important. So, what is the state of charge, state of health? Okay, like as our health. What is the health is there? Same as a battery health. The good condition or not. So that is the main thing here. The battery management system will be discussed about of in, but what of the IoT and AI, how to apply for that one, and go to from practical class also. I will discuss about that one. So, like as for that one in IoT, okay. So you know the sensor, connectivities, data transfer, within fit. So different type of IoTs means like as IoT means it's not for Internet of Things. It will be some components, the sensor, how to battery monitoring, how to controlling of battery. It will be connecting to signal from one or two vehicle, the moving of batteries, or for any signals, anything also. It will be there. So that is the introduction of battery management system. So how IoT and AI can improve the battery performance? The two most important factor in battery performance are charge density and cycle life. Listen here. So charge density. So density is there. What type of density is available? High energy density, not a power density. In ultra capacitor, high power density. In battery is high energy density. What is the energy formula? Energy is equal to integration part of P into TT, depending on timing. So here's the good. So it will be good condition battery. So mean improve the life of the battery in memory system. Okay. And in IoT and artificial intelligence can help improve the battery performance. A lot of these technologies are already will be there, but here I'm using for that one. It will be how to create, how to justify, how to inform to the owner of the vehicle the battery safety or not. And IoT artificial or performance battery management system, a technology will offer because they are difficult strength. Will IoTs primarily focus on getting data? So what happened? IoT is gathering data from device. Which device? The battery or vehicle is moving. Vehicle is moving. What condition is there? The battery condition. Also analyze this data. First you take the gathering the data and next analyze give there. So there is a processing. What is the main role of this IoT? Doing first gathering the data. What data is there? What is the condition of battery? What data will be there? That is the gathering and processing. And this processing. So the main function of IoT are here in my vehicle. One is the collect, communication, analyze, and action. So here data, gathering data from sensor and various other devices. So from by using sensor to gathering data, what is the battery condition? What is the motor condition? What is the vehicle condition? Is good or not? I'm traveling of 200 kilometers. I'm traveling of 200 kilometers. The battery capacity is okay or not? What is the health of the battery? Okay, how much charge is there? What is the capacity of charge? It will be informed for the data. It will be first of all in collect the data from sensor. Next to communications. Send data to such a cloud. So communicate. How to communicate in sensor? So it will be collect data from the battery and communicate it to this vehicle. So mean the personal data of communications together by using Wi-Fi, 4G and 5G. It's the communication data is there. Analyze. Collect the data information from the raw data to visible to get a report and keep. So it will be processing. After that, machine to machine action based of analyze communication, other devices through the machine to machine protocols. So it will be there. So that is the main function of this one. The main function of this main function of this one. So here, so the main components, this is the main components of an electric vehicle. One is the motor. Suppose here nowadays all of you different type of motors. There is a motor AC is induction motor or this is BLDC motor. BLDC means brushless DC motor and controller. The controller means the controlling of total body of the vehicle. Is controlling of motor, is controlling of throat, the controlling of battery, the controlling of converters, to controlling of wheels, and to controlling of temperatures, everything also, and charger. So what type of charger? Onboard charger in vehicle, next converters or inverters. The converter means it will be DC to DC converter. Suppose the input is battery, output is BLDC motor. There is a DC to DC converter. It is converting from low voltage to high voltage or DC to DC, variable DC to fixed DC. Like I said, chopper. It's the inverter or inverter. Inverter means suppose output, the current motor is AC motor, there is a AC induction motor. Suppose not using the BLDC motor, suppose using for AC induction motor. So that is more by using inverter. Inverter means what is the principle of inverter? It is converting from DC to AC, the battery. So nowadays all of it using for lithium ion battery, a lithium ion sodium battery. Lithium ion sodium battery. That is a very, very important the function of the battery. The function of this battery. So there is the same parts will be using for here in parts of the electric vehicles. So listen here, what is the structure? What is actually electric vehicle structure? And after that, how to controlling of by using IoT. Next one is how to controlling of by using. What is the role of IoT AI in electric vehicle? First, what is the electric vehicle? What is the kind of is there here? So I am discussed about already in things here. The same as for that one. So the first ear function is the onboard charger or outboard charger. Anything also here. Okay. This is structure of electric vehicle. So here the main parts is four parts. One is the battery, converters, motor, and wheels of the vehicle. The power transfer. This is the motor. Before is the inverter or converters, the charging, and before will be battery. The same structures will be there here. So what is the power flow and one direction and regenerating of power. Second one is regenerating of power. So here first of all the power supply. So your power supply is connected to this battery. So here two types, I mean two way of converters. With charging of the battery. One is the normal charging, one is the normal charging or on or check and quick charging. One is the normal charging is connected to the onboard charging is connected to the battery. So battery will charge. This is one part. And next is quick charging. Quick charging means to apply the DC voltage, high voltage application. That's a different type of charging station is there. Different type of charging station, low voltage charging station, medium charging station, and high charging station. So it will be there. So what happened here? The first on direction, there is a charging to driving process. That's a charging driving process. So it will be battery will charge. Battery will be charged. So first before there is a only for power supply to charging. So here normal charging, onboard charging, and quick charging. Quick charging voltage is 440 voltage in AC or 11 kV means in DC. The quick charging within few of second, within 5 minutes or up to 5 minutes will be charged, quickly charge. And next is connected to the inverter. Why are using the inverter here? The inverter means it's currently from DC. So input of inverter is DC, output is motor. Motor means suppose here using the AC motor, it is using the AC motor, there's a AC induction motor. So by using of inverter, suppose here in place of motor, by using BLDC motor, so the inverter in place of by using converter, there's a DC to DC converter, and motor is connected to the car drive. So here between transmission. So what happened here? The motor connected to the transmission. So there is a one forward path. Suppose in braking point of view, so in braking point of view, some generating. There's a regenerative braking. So back to charge the battery. So there is a series electric vehicle. Like I said, this one of the series electric vehicle. Like I said. So all of you for nowadays using for only series electric vehicle, not a parallel and hybrid. It will be the battery management system with IoTs and IoT. So now let us roll up the battery management system in electric vehicle. That is how you integrate IoT and AI in battery management system. and different technology. Suppose I'm show the diagram in this diagram. So that is controlling how to battery memory system here. So listen here. This is a vehicle. One vehicle is there here in sensor before vehicle. This is okay. The vehicle is connected. Okay, now. So what happened? The vehicle it will be edge intelligence. So mean state of X emissions. Listen, state of charge means state of X means X is different. X is available here. Different X is available. The state of charge, state of available of power, state of health. Here three stuff. So means what happened? So here battery management system means so everything is good condition. The battery also the good condition. What is the main function of battery? Which is the main thing is a battery here. One is the sorry, state of charge, state of available power, state of health. The three point is important. That is a state of X estimations. Next one is onboard ratings. Limit of maximum temperature, limit of SOS, maximum SOS. What is the limit of SOC? SOC means state of charge. What is the limit? So listen here, not a maximum charge your battery. The battery will be damaged immediately. So with of life is very less, more charging. So of course, your mobile or your vehicle battery charging up to 90 percentage or 95 percentage, not 100% will charge. 100% will charge, the health will be damaged. Health will be damaged. Health will be damaged. So that is the one thing. And next one is maximize state of health. So there is the onboard variations. So listen here, in case of so here voltage in sensor in four combination of sensor in this battery in battery management system. One is the voltage. What is the voltage rating of this battery? Suppose in a battery in 2 voltage or 48 voltage or what things 48 voltage is to current. What is the current in AH ampere hours? Ampere hours. What is the capacity of battery in AH? AH means ampere hour. So what is the capacity in suppose I'm designing a college in one vehicle, that is a bicycle and tricycle, and go to one scooter. Three vehicle be designing recently one year back, recently in this year also one vehicle. So in first I'm designing a bicycle. The voltage capacity is 12 voltage means battery voltage. So not a one battery will be, I'm taking the two battery 24 voltage. I want to 24 voltage motor. Okay, 24 voltage supply the motor, vehicle to motor. So here designing of battery in two battery be connected series 12 plus 12 24 voltage. So in 12 voltage and capacity is AH, that is 7.5 AH. In series the current will be same. What is the capacity of battery? 7.5. So here this is very important. This is the very important. One is the sensor is one is the voltage sensor, current sensor, temperature and associated. So here in temperature, what is the temperature? So not more the temperature. Maximum temperature of battery is 35 degrees centigrade. The more than 35 degrees centigrade will damage. So recently in Chennai and some areas, will be some blast of the vehicle. So temperature will be increased more and more. So how to control the temperature? By using hybrid methods, by using hydrogen or gases. I'm also work for the battery management system and that one. So that is important. So what happened? And recently, suppose in car and suppose in scooter, e-bike, the capacity of motor is the capacity of motor is voltage capacity is 48 voltage. 48 voltage. In 48 voltage is very, very important. And that matching of this controller, the controller matching of the motor. So means one capacity voltage will be compulsory. Suppose motor depending on motor. Suppose you want a motor 1500, 1500 or 1000 watts and a 1 kilowatt motor. Capacity is 48 voltage. So that will be 48 voltage means the battery voltage is also same. Or so battery voltage will be changed by using this converter. By using converter means there's a boost converter. So it will be increase the voltage from you want to 48. So here only 2 voltage is
Anyway,
there. So it
I'm
will be increased 2 voltage to 48 voltage. Step up the voltage. So it will be considering here. And here it will be there in processing of that one, the electric vehicles. This is the vehicle. The sensor base is available. The electric vehicle is connected to sensors and show the one diagram and real diagram. Recently, I have developed the one sensor based electric vehicle. So here, so sensor is available in sensor. And up of that one is the communications and cloud and connected to this data. So what is data is available and connected. So this is the processing of in IoT supply. This is the processing of IoT apply. So here digital health, recognitions of here remaining useful of life. Okay. And what is the cloud? Cloud means store the data. What is it for the cloud? Cloud technology means storage of data. The IoT, Internet of Things. So the total data will be stored in cloud only, and cloud will communicate to this vehicle by using in communication system by using 4G or 5G. So nowadays all of you 4G and 5G also. So the 5G data, there is a 4.5, 4.0 IoT by using here and develop for this one. So there is a overview of in IoT is connected to the vehicles. Suppose here what will be changes, temperature will changes, inform to our particular what happened vehicle to send the mobile, the communicate to the mobiles. So your battery is not safe. The battery temperature will be increased. The wood will be changed. The capacity is less. Okay, energy is not sufficient. Even traveling is up to 200 kilometers, not 300 kilometers. After 30 kilometers, you're traveling. After the battery will be dead. Instead of that, SOD, instead of death. So, like as for that one. So, that is the one thing is available here. That is a thing. So, that is the main advantage of by using IoT to apply the electric vehicle. The safety purpose, the human safety purpose, or any signal is there, the capturing of signals, and suppose some problem is there here. Oh, over speed, it will be the vehicle is maximum speed 60 kilometer per hour. So go to 80 kilometer per hour. It will be intimate. It will be signal to the particular candidates, the owner of this vehicle. So inform to you to send the message, communicated
in
to
Delhi. How's the
sensor to
news which
human
is
body.
going on
So like as for that
television
one, that is
channels.
very
No, no,
important.
rain is not around.
The
There
same
is
as
a
for that
different
one, that
news
is
which
state
is
of
going
charge,
on
state of
television
power
channels.
available, state of health. That is very important. And it's suppose means in technology by using for IoT and the systems. Like I say in 4G, 5G data connections will be there. Okay. What is improve the performance is there. What improvements here improve the health of the batteries, health of the batteries. Some of benefits. What are the benefits of integrating battery management system with IoTs? So here, no thing. One thing is SOX. SOX estimation. SOX means state of health, state of charge, state of depth, state of power capacity. Battery demonstrations, and it will be data collection for processing, the measurement of energy storage in a battery and amount of charge required. There's a smart charging. So what about would the rating of suppose the battery full charge or not? So to display by using IoT. So you are okay. The good conditions battery, the full charge, 85% is good. Okay, so that will be important for that one. This is the more benefits of in battery management system with IoTs. With IoT, this is the conclusions. This is a better thing is available here. And what is the IoT battery system monitoring? I think questions will be given to here. Monitoring battery performance in real time. Identify when battery needs. Find charging stations near to system. Determine the battery in charge computing of trips. That is some using for that one in IoT in battery management system, role of IoT in battery management system. And here, benefits of using IoT means it will be monitoring the battery performance, the real time, and take corrective actions to avoid the production of battery issues. So listen here, I think this is one of the small model developed for our college, means my students recently. It will be vehicle. Okay. I think this is the sensor. Before to this is a no sensor. This is a small battery. There is a 5 volt is battery only for one battery is 2.5 Ah capacity, 3 voltage. So in three connected series and a small motor will be there here. This will be what happened. It will be receiving for here, and this is the Arduino will be sensor and vehicle. So it will be any traffic point of view, in over speed point of view, it will be communicated to human. It will be over speed or more problem is available in battery also, everything also. Like as this one, like as in this one. This is one of the vehicles will be divided as. Thank you. For anybody, any queries?
Participants are requested to have interaction with chat box. Uh,
Okay.
uh, if you want to put some queries, you can go ahead right now. Okay. Uh, I think, yeah. Yeah, sir. Can you hear me, sir?
Sir, yes, sir.
Yeah, it's end from your side right now.
Okay, sir. Yes,
Yes.
sir. Yes, sir.
Okay. Okay, then same topic will continue be in the here itself, huh? Because next guest is joining little late, no? So we'll talk something on the same topic. Uh, okay, sir. Be here, sir. Okay, Ramesh, sir.
Thank you, sir.
Okay, okay. Be here, sir. Okay.
Okay, sir.
Participants, if you have any queries, you can put it in the chat box. Participants can. Krishna, is it possible for they unmute themselves?
Yes, sir. I will unmute the participants' mic.
Little bit for small time you can unmute, and if they don't want to say anything, then you can mute again. Yeah,
Yes, sir.
participant, do you want to say something?
Yes, sir. Now participants can unmute their microphone.
Okay, okay, okay. Participants can speak. If they have to speak something, they can speak. Okay, Jayshree, Vijaya, Mamta, Ramnika, Sonal, Suhas, Supriya, Swati, Tukaram, Vijaya. Anyone want to say something? Yes? No. I think their microphones are muted. Okay. Okay. I think they understood. So, same thing, sir has explained the the battery management system for electric vehicles remotely through IoT environment. And I think it's one of the important core segments which we'd like to try. The same last class, I think Dr. Prasad Acharya has given some MQQ file also in software. Some demonstrated he did last class. I think it might be with you. Just 1 minute. I will share my screen. Yeah. So time being, just sir, I will screen my share screen. Just I will ask same thing. I will see some program.
Yes, sir. Yes, sir.
Yeah, we'll see some program for that. Now, please, first of all, you tell me in the chat box how many are aware. Yeah, yeah. Lecture was nice. Durgesh sir is saying thank you. Yeah. Uh, Participant, how many are aware about the Replit compiler? If you are aware, you can say yes. If you are not aware, you can say no. Yes, Durgesh? Yeah. How many are aware of the Replit compiler? Yeah, no. Nitin sir is saying no. Durgesh saying no. Kalpana, no. Okay. So first of all, I will give you one compiler link here in the chat box. You have to open that compiler in your this one laptop. So I will give you one compiler link to you. So simply what you have to do is I will share my screen before proceeding so that you'll understand. Yeah. So you can see this is my screen over here, and you can see there is a Replit Python. So you have to browse here Replit Python, and then you can click here on the Replit online compiler. So you have to click on the Replit Python online compiler. Yeah. So here Kalpana, Durgesh, Nitin sir, Durgesh, you got it this? Replit Python. So just Python 3 you can select. So just the link I will put it in the chat box also. So you can see this is a link in the chat box also. So this compiler you have to open it. Replit compiler you have to open it. Yeah. So yeah, yes, Krishna has opened. Anyone else has opened this compiler? Then you can put it on the Python. So I'm expecting answer for the participants, those who are here. So you can click on the Python over here, and then you can say here, Replit, the Python Replit, you can say here, and then you can say create a Replit. You can say create a Replit. So this Replit compiler is now open. Those who are having this compiler, you can say me yes. Those who are having any trouble, they can say no. Yeah, speak in the chat box.
Yes, sir, I have opened it.
Yeah, you have opened it. Anyone else has opened this compiler? Kalpana, Durgesh, Dr. Nitin. Got it, this compiler over there with your laptop? Yes. Yes. I need answer from the participants. It should be two-way interaction. So you got it? You can say yes. If not, you can say no. Okay? Now,
Sir, the participants' mic is on, so they can unmute themselves.
yeah, they can unmute yourself and they can talk. Participants, they can talk. Okay? Yeah, participants, anyone else? Yeah, Durgesh, they are saying no. So this is a Python compiler. And yeah, then as Ramesh sir has beautifully explained the battery management system in IoT environment, how to access. So last class, as I told you that the this Govind Prasad Acharya sir has given the demonstration about this this MQTT file. So you can see this is a screen where, as Ramesh sir has explained, the same thing you will be able to demonstrate through the IoT environment. So in the last class, we have seen that there is a MQTT client. Last class, we have seen this MQTT client. I think my screen might be visible to you. Yeah. So you can see, as Ramesh sir has beautifully explained, this battery management system for electric vehicles, because nowadays you might be aware of that driverless cars are coming in the market, and because of the fuel issue, the electric vehicles are picking up the demand. So universities and governments throughout the world, they are trying to boost for electric vehicles. So for that electric vehicles, the management of the battery is very, very tedious task and very important task also. Suppose, for example, our mobile phone needs, if it is consuming more power, our mobile phone consumes more power, then we need a huge batteries. So nowadays solar vehicles, so one of the core objective for the solar vehicles is this battery should last for a long time. I think everyone, those who are in the panel here, they can easily understand what the importance of the battery. So through the IoT environment, we have to do the management of the battery. So management means basically how much the current battery can draw and how much time this battery can last, how many kilometers the battery can go. Suppose while charging also, how much is a over voltage is getting charged, how much is a deep discharge of the battery is there. So for management means battery got some criteria. As one is a overcharge protection, deep discharge protection, over voltage protection, under voltage protection, the current drawn current protection, etc. And so on. That's what it is called as a battery management system. In this battery management system environment, first of all, we have to go to the replete the Python, the compiler we have to go. And in the Python compiler, as the client and server, which Govind sir has already briefed. So there is he has explained the protocols for IoT. So one of the protocol is a MQTT protocol. Okay, message queue transfer, the what we have seen in the MQTT protocol. So in this Python environment, either the we can have a Python portable which is downloaded with your system, or you can open this compiler, the live. So we have a program is compilers and some other compilers. I think compiler, you might be aware what the compiler is. So whenever you are trying to do something, so initially you have to import the packages required for. Suppose here as Ramesh sir has introduced the battery management system for electric vehicles, then you see first of all you have to import this the MQTT protocol. Then you have to import the time. Time is also required. How much time? Because just like in our C programming, also the math library we can import, or the numpys in Python, the pandas in Python, which we have already seen. So similarly here we have to import the MQTT, and then you have to import the time, and then you can import the package. That's what is a random package. These are the libraries we have to install for our Python environment while going for accessing this battery management through the remotely through the IoT environment. As suppose for example GPS car or driverless car is there. So suppose here as sir has talked about the battery, so you can see first of all here you have to define the we can call it as a dictionary definition, we can call in Python. So the class is a battery, for example. So this is a class battery, and you can define here the self and initial charge of the battery. Suppose initial charge of the battery is for example some 50 unit, or you may change it some other, and then capacity of the battery. So then the capacity of the battery, you can define the capacity of the batteries for suppose for example it's a 100. I think some people may be aware or some may not be aware what the capacity of the battery is. Now, for example, it is a 1 ampere hour battery is there. 1 ampere hour indicates that this we can draw 1 ampere current from the battery, and it will last for 1 hour. Suppose our car is drawing 1 ampere current in continuous rating, and then it will stand for us for our vehicle for around 1 hour. So our car speed is for example 40 kilometers per hour, then 1 ampere hour battery, and if current of the our motor or drive of the our vehicle, which Ramesh sir has underlined, so that battery capacity is for example 1 ampere hour, then you can go up to 40 kilometers and so on. So naturally, if you want to go for suppose 80 kilometer, then naturally we need a 2 ampere hour battery. So that's what the battery capacity. So then you have to say that cell capacity of the battery, and then the charging, the initial charge of the battery. So that's what in the Python environment you can define, as I told you, the initially MQTT, the communication protocol when we are trying to access the battery parameters or the management through the remotely or through the IoT environment. Then this is a definition of the battery. Yeah, capacity. Yeah, Durgesh is saying capacity of the battery. Yeah, capacity of the battery means just I will here for example. Yeah, capacity of the battery means yeah. You see, for example, this is our battery. This is our battery, and for example, this electric vehicle is connected to our battery. For example, the capacity of the battery, suppose for example, 1 ampere hour. 1 ampere hour means, suppose for example, for our vehicle, this is our drive for our vehicle. This is electric vehicle drive, and that drive is connected to the battery, and also the light or some safety parameters or GPS. So all devices put together, the current of our battery will be 1 ampere. Current of the battery will be 1 ampere. If 1 ampere is the current, total current drawn from the vehicle is 1 ampere, and battery capacity is 1 ampere hour, then we can drive our car up to 1 hour, clock hour. You can drive up to 1 clock hour. Suppose our vehicle speed is 40 km/hour, then you can determine that our vehicle battery will last after 40 km. Suppose for example, you suppose your battery in the same scenario, you suppose battery capacity, suppose for example 2 ampere hour, then our car, we can cover with our car how many kilometers, Durgesh? With 1 ampere hour, you can cover up to 40 kilometers. Then 2 ampere, if battery is the capacity, then how much distance you can cover? Durgesh? Very good, boy. Very, very good. Very good. I'm very happy. So that's what the battery capacity. I hope you understand what the battery capacity. Now, battery management means we have to manage the current, we have to manage the voltage, we have to suppose we have to manage suppose over voltage, we have to manage suppose deep discharge. So these are the some of the battery parameters which we are going to manage. So generally in the general thing, we have a different electric circuits, just like the overcharge control protection, we can call it as some protection arrangement. Suppose it's a deep discharge, or suppose overcharging, or dry run, etc. So that's what the parameter. So in our program here, we have taken a replete compiler, and here you can define the capacity of the battery. And in the Python here, this is a compiler. I think if you are not aware of the compiler, then at the end, if time permits, then I will try to tell you how to do the. Once again, I'll repeat for that. So once again, those who are saying no, initially you can see here, you just simply put it replete. Okay, you can just put it there, replete. Okay, okay, replete you can put, or you can put it repel in the Python. So you will get replit browser will get open. So with that browser, just you can pick up, you can put it here, this browser over here, and then you can just put it here, the Python. You can select the Python, and you can say create a replete. So you can put it here, the create a replete. So this environment will be there. Basically, it's an online compiler for Python. Of course, here so many compilers are there, but as of now, the Replit is one of the best compiler we can call, because the in the other compilers, few of the libraries required for the IoT environment or AI environment, we may not be able to take the packages or install the packages. For that, it's very difficult. So here, this environment, most of the packages can be automatically installed. Not all, but most of the packages can be installed. That's what the Replit compiler is. So initial step is to open the Replit compiler. How many got the compiler? Please say S in the chat box. How many understood how to open the Replit Python compiler? Please say S.
Yes, sir, I understood.
Yeah, Durgesh is saying yes. Okay, anyone else? Yeah. Durgesh got how to open the Python compiler? Yeah. Next, anyone? Those who are in the meeting, if you couldn't understand how to open the compiler, please say no. If you say, yeah, yes, Sonal is saying yes, very good, very good. So in this way, you have to open the compiler. And once we open the compiler, then what the Ramesh sir has briefed about the battery management system for our electric vehicles in the IoT environment. So that thing we will be able to easily implement it. You can see it here. As I mentioned you that the initially the different packages we have to install. So as MQTT protocol, the communication protocol in IoT environment, which is explained by Dr. Prasad Acharya yesterday, and today Babu sir has already explained about the electric vehicles and the remotely management of the battery and so on, same thing. So here the in the dictionary environment, the battery is to be defined. So up to this point, everyone, is it clear to you? Of course, I will guide you how to do it. But if you understand up to this, conceptually, you can say yes. If you know, you can say no. Yes, anyone? Yes. Durgesh, Sonal, Dr. Nitin. Is it clear up to this point? Yeah, yes, they have understood. So here in the Python environment, yeah, Sonal, yes. Yeah, in the Python environment, you can define the class for the battery. And for example, suppose as Babu sir has explained about the battery. So the one is the parameter for the battery. Different parameters will be there, but one of the parameter for the battery is the discharge. So here you can see the we can put it here the function for the battery, which is a package of MQTT as the client server environment, as in environment as earlier we have seen in the last class. So here there will be self and there will be amount. So how much time that battery can work, or how much time the battery can last. So that's what the amount. And suppose battery is discharged up to the particular limit. Suppose, for example, the in terms of voltage, if you talk about suppose battery voltages, in terms of voltage, I am talking right now. Suppose battery voltage is suppose 12 volt, and once start our vehicle use the Nitin sir, thank you. As the battery will starts using it, then naturally the voltage may drop sometime. And suppose, for example, voltage drops more than 10, then more current will increase and battery may get damaged. In order to avoid that, we have to put the cutoff limit for that. And that cutoff limit is again a Boolean. I think Boolean you can understand. It's a true or false. The Boolean value is 0 or Boolean value 1. So if it is a battery is either 10 volt above or below the 10 volt, then our battery should switch off the power. Otherwise, battery may get damaged, because battery is again costly and it's very difficult for us to do the compromise on the battery. So suppose here cell which is a Boolean, if the amount of this particular voltage is lesser than 0, and that's what the charging. So if battery is for example self-charging mode, and then suppose self-charge equal to the amount and the return value the true and return the false. So that's what this will be able to understand through this. The one of the parameter for the battery is the charging, whether battery is fully charged or not. If it is fully charged, either yes or either no. If it is discharged in particular limit, either yes or either no. That's what the we can write it in the here the Python environment. Now moving further, then you can define, for example, here the charge battery. This is a function we can define, and which we have defined as a the Boolean. In the Boolean, self-charge plus the amount, and which is the self capacity, if it is equal to less than 0. So if the battery is fully charged, or battery is partially charged, or battery is not charged. So here in between will not be there, either charged or either not charged. That's what the Boolean we have defined over here for the battery through the IoT environment. I think till now it might be understood very clear that a vehicle might be running on the road, And for example, we might be sitting somewhere else, or so our robots or machines will be, controllers will be some at standstill location. And via internet, through the IoT environment, we should understand in the driverless car, electric vehicle, for example, we should be able to understand how the battery is behaving, or how much time the battery will withstand for our vehicle. I think you might be aware of that. For example, one driver is required for one car. Then in the words, you see how many drivers are required. If you go for example, driverless car, then that many drivers, that much amount we can save. So that's what the GPS controlled electric vehicles, we can control the battery, the car, as well as the here, as of now, the Ramesh sir has underlined the topic. That's what the charging management and all. So that's what the battery we can control remotely, though our car is on the road. That's what the capability or power of the IoT environment. I think you might be aware of some software domain. The instant driver, we may think that driver is not there means what's exactly. So if driver is not there, then that's will be the software agent. So that's what the expert systems are inbuilt. I think you might be aware of the expert system. For example, doctor is an expert. So what the knowledge he has, that is inbuilt in the software. So instead doctor we can call it as a expert system. Similarly, there is a software agent, and we can call it as a expert system, which is our car is embedded with the expert system. And that's what in the environment we will be able to maintain the car. And here our topic is the battery management in the IoT environment through the MQTT protocol, which we have seen in the last class. Similarly, here the class in the IoT environment. So there will be the initialization function is used. So you can see we can define the underscore initialize and self. And here we are taking care of the battery. So here is a self battery. That's the IoT environment. You can see here you have to define, because we are trying to extract this information through the IoT environment. So here you can define the function. That's what the class IoT environment. And then you can initialize the function, the initialization function, and then the cell battery, and there is a battery function. And then suppose battery is low, or battery is fully charged, or battery is deeply charged. What the boolean the message is there, that message is extracted or retrieved from the vehicle at the controlled wherever the car is being controlled through the GPS. So that message is being transmitted. So that message transmission, as Ramesh sir has underlined beautifully, that the car and the hardware, as sir has explained. So here you can have a message over here, and that message is being transmitted. Either battery is enough charge or battery is discharged. So that IoT environment, you can have a IoT, and the message is being transmitted in the client environment, and the self, the client, and the user data message. And then further, the payload. So payload, that message is payload, and we can decode the function. And if message, the command is a discharge, and the payload. So how much is the amount, and that you can define further. And then the battery print the charge amount. So how much amount of the battery or the charge is available, that charge battery is being printed. The message will be transmitted from the battery to the controller, or controller can get the message. So the same message will be displayed on the screen. So for that purpose, we can use the function. That's what the print battery function. That's a print battery charged by the amount and the unit. And else, if the message, you can have a command discharge, and then finally you can have a battery is discharged by how many units. For example, at the beginning, the battery is when the car is started, the car is the charge is 1 ampere unit. Actually, it might be some 100 ampere hour or 50 ampere hour, as the mobile you might be aware, which is in milliampere. So 100 or 1000, we may say that while purchasing the mobile, we may say that my battery may last for 5,000 milliampere. That's what when we design any embedded system, then the capacity of the battery is too important. Otherwise, your mobile phone is usually smaller size and battery just like a vehicle battery, then it looks odd. So our devices should consume the power as less as possible. That's what the idea behind it. And then you can print it here. So if battery unit is, suppose if you want to know the battery unit, suppose it is an ampere hour, or it might be in watt, or might be in kilowatt. So that unit is there. Then that unit will be printed. The amount of the battery, that particular unit will be printed through the message. And the unit is something different. Then we may say that the print invalid command. So if you are looking for something else than what the battery power, which is the charge status, then you can have a invalid command. And then again in IoT environment, as we have seen earlier, you can have a client and as we have seen in the last class, MQTT protocol, the communication protocol, which we have seen in the last class, and the client function. So we can use the client function and MQTT protocol, and you can have a message that is a self on message. So client self on the message. And then further, the local host. I think you might be aware of that is a client and server. I think whenever data is being communicated from car to the GPS location, then one will act as a client and one will act as a server. So that local host, the code defined by the International Union, that's what the suppose 1883 is the code. I think code might be 200 or code might be 400. I think we have to go further for the application. This is what the environment, interface environment in the web browser domain. So again, I will brief you about what the 200, 400 codes, the queries rise and so on. But as of now, the code for here is the 1883. And the client, you can subscribe and the loop start function. That's what the commands and the hashtag. And if it is true, then you can say suppose battery will be in sleeping mode. Sleeping mode in the sense the sleep function. That's what in the time domain. And then you can print in the battery charge, which is a cell battery charge, and the battery capacity. That's what the printing is required. And here again, if you initialize the name and the main function, then you can have a Internet of Things, that what the sir has underlined, the IoT environment and the IoT environment function. And then you can end it with the IoT environment and with the help of run function. So this is what the program, as the sir has underlined the hardware, and just we have extended the same topic with the how exactly we are trying to operate in the IoT environment. I think we might have made some justice for this particular topic. I'm very much thankful to Ramesh sir. Ramesh sir, are you there right now? Yes, Ramesh sir, can you unmute yourself if you are there? Yes, Ramesh sir. I think his technical issue. Yeah. Yeah. Anyone want to say something? Is it clear to you? Put it in the chat box. Else we have to proceed further. Yes. Sonal, yes. Yeah. Okay. Once again, I'm very much thankful to Ramesh sir and over to Sai.
Yes, sir.
I think Pratik sir is also in the meeting. Yeah.
Yes, sir. I'll make him co-host.
Yeah. Go ahead. Yeah. Sai, go ahead.
Yes, sir. So our next speaker for the session is Mr. Pratik Tavde, sir, who's currently working as a lecturer at Vidyankar Polytechnic, Mumbai. Sir, on behalf of IETE Pune chapter, Buzz Engineering Academy and Civic Incubation Center, I welcome you to the virtual dais and I request you to take over the session.
Okay, thank you so much. Am I audible, sir?
Yeah, you are audible. Very happy
yeah.
to see you. Yeah, you are audible.
Okay.
Yeah,
Okay, yeah. Good evening, all of you. So today I'll be taking a session on virtual reality and augmented reality. So right now I'm sharing the screen. So just you can stop sharing. Okay, thank you so much. So now I'll share the screen. Just once the screen is visible, kindly give me the acknowledgement. So I hope screen is visible, all of you.
Wha-
Yes, sir, it is visible now.
Okay, fine. Thank you so much. So without much ado, let's start with the session. Today I'll be taking session on virtual and augmented reality. Now it is very important when I talk about artificial intelligence and machine learning. When I talk about artificial intelligence and machine learning, there is one of the important major role, that is AR and VR. In short, abbreviated as virtual reality and augmented reality. So let's understand when I talk about virtual and augmented reality, there are various immersive technology like mixed reality, augmented reality, extended reality, and virtual reality. Now, when I talk about reality, is there anyone who can tell me from your side what is reality and what do you mean by virtual? If any of the participants could put it in the chat box, it would be great helpful. I wanted to know from your side. The session should be interactive, all right, all of you, so that I'll come to know what is reality and what is virtual. Okay, fine. So let's understand when I talk about reality, virtual reality to be more specific, virtual reality is a computer generated environment with sense and objects that appear to be real. So basically, when I talk about computer learning or generated environment, it appears like an object, and it could be a two-dimensional object or a three-dimensional object, making the user feel they are immersed in their surroundings. Actually, object or image or instruments you are not handling physically, but using some of the other technologies, using computers or some AR, VR related devices, you are going to feel, actually, you are going to do the practicals without actual handling the actual instruments which are available in the laboratory. All right. Today, once the theory parts gets over, I am going to share you some of the videos also, so that you will come to know actual hands-on how exactly practicals could be done as a teaching learning methodology beyond syllabus practicals, whatever you are studying in academics, apart from theory, you can do as a problem-based learning using virtual and augmented reality. So let's summarize. When I talk about virtual reality, it refers to generative virtual environment or projection, which creates a realistic experience but does not exist in reality. Now you can see there are two simple examples which you can observe. On the first left-hand side of the image, a person is driving a bicycle. And in the second, again, some of the picture is there. Now let's understand what is the exact difference between the two. Now there is another virtual example, virtual museum tour. Now let's understand how does virtual reality works. VR system work by simulating as many senses as possible to trick the human brain into perceiving the virtual environment as reality. So basically there are certain softwares and hardwares which are required in case of virtual reality. Let's understand what are the hardware components required in virtual reality. So you require head-mounted display, in short abbreviated as HMD, headphones with special audio, gyroscope, accelerometer, magnetometer, forehead and motion tracking. Then certain controllers are required, gloves and treadmills. So these are the hardware components required for virtual reality. How VR works. So now you can see a person is standing and with the help of some of the device which is put on the eyes like a camera, and you can actually feel or you can do the practical hands-on. using any subject. For any subject, you can do the practicals. And this can be related with artificial intelligence, machine learning, and obviously, last but not the least, that is Internet of Things. So basically, these are the various VR headsets. Now you can see in the previous image, this particular girl, whatever she has put it in her eyes, that particular device is known as Oculus Rift, which is very important hardware component which is required. Then you always also require a Samsung Gear, Google Cardboard, Google Daydream, and HTC VIVE, that is Vive, HTC Vive in short. Now let's understand what are the various VR use cases. So you have a gaming industry wherein virtual reality can be used. You have real estate, hotel industry, amusement parks, research facilities, education. Nowadays in education also, there is innovative teaching learning methodology is required because same subject, if some of the professors or faculties are teaching for so many years, let's say 15 or 20 years, same subject, but there has to be some innovation in education as a pedagogy. All right. So in education, augmented reality and virtual reality is very important, which plays very important role as a innovative teaching learning methodology. So AR, VR is very important, and obviously artificial intelligence and machine learning as well. So let's understand how exactly virtual reality history, how it was started. Basically, it was started in 1930. Science fiction story predicted VR. The idea of a pair Google that let the wearer experience a fictional world through holographic smell test and touch. After 1930, we in another year, that is 1950, we have Morton's hanging sensoroma. He has invented his history of VR, and he talked about which is an arcade style theater cabinet that will stimulate all the sense, not only sight and sound. In 1960, the first VR head mounted display by Morton Helix telesphere mask patented in 1960 and was the first example of head-mounted display. In 1961, HeadSight, first motion tracking HMD by Komeyu and Brayon. In 1965, the ultimate display by Ivan Sutherland. It simulates reality to the point where one could not tell the difference from actual reality. It includes virtual world viewed through HMD, computer hardware to create the virtual world, the ability users to interact with the objects in the virtual world. And finally, beginning of VR by Jaron Lanier coined the term virtual reality. So this is very important. He was the first scientist who coined or invented this particular concept, something called virtual reality. Created one of the first company that sold VR-based products, considered one of the most influential computer scientists in VR history. So this is a history of VR, whatever we have done or seen so far. Now let's understand what are the different types of virtual reality. The first one is non-immersive virtual reality. Then you have fully immersive virtual reality, semi-immersive, and collaborative. Now let's understand each one in detail. What is non-immersive, fully immersive, semi-immersive, and finally collaborative. Non-immersive virtual reality. It is a computer-generated environment without the feel of immersion. Basically, it will be like a computer-generated environment. You are not actually doing it, but you will feel you are doing it as a hands-on, any of the practical or let's say gaming industry and so on. Then the other type of virtual reality is a fully immersive virtual reality. It gives you a sense of being present in that world, virtual world, and everything is happening to you for real. It involves helmets, gloves, body connectors with sense and detectors. Semi-immersive virtual reality, a mixture of non-immersive and fully immersive virtual reality. So when I talk about semi-immersive, remember basically it is a combination, it is a mixture, it is a hybrid of two technologies, that is non-immersive and fully immersive. And finally, last but not the least, we have collaborative virtual reality. It allows users to collaborate in virtual reality from remote locations. All right. So now I'll stop sharing the screen and just we will actual video how practicals could be done using virtual reality so that you will get actual hands-on practice. All right. So just give me a second. I'll share the screen and just let me know once the screen is visible and video is also audible and visible. All right. Just give me a second. So basically all these practicals are developed by me in virtual reality. I hope screen is visible all of you, right?
Yeah, yeah.
Yes,
Screen
sir,
is
it
visible.
is.
Okay, fine. Just it is loading, video is loading. Just have a patience. Kindly give me the acknowledgement once the video is audible and visible also. Just give me a second. So all these are videos for electronics and telecommunication students, and not electronics and telecommunication, computer and IT students also has these particular subjects for digital technique, basic electronics, Zener diode, VI characteristic of all diodes, then CE amplifier, voltage regulator, power supply. So all these practicals I have done using virtual reality. Environment is created and innovative teaching learning methodology is achieved. The students are enjoying a lot using this AR VR technique. Okay, so you can see this first practical measure the resistance, voltage, and current. Now everybody knows this particular concept. Whenever the resistance are connected in series, the formula is R1 plus R2. And when the resistance are connected in parallel, it is R1 into R2 upon R1 plus R2. So just video is loading. Just give me a second. Just let me know once it is audible and visible. I hope screen is visible, all of you.
Yes, sir, it is.
Yeah.
Okay, fine. Now I'm playing video also. So just let me know once it is audible also.
I think video is getting loading. Yeah. Yeah. Can you hear me, sir? Pratik, sir?
Yes, sir. Yes, sir. Video is
Getting
loading.
loading.
Just have a,
Okay. Okay.
yeah.
You try, else we can share them also in Drive later. No issue. I think some technical issue is there with sir. Uh,
So till then, I'll share the midweek feedback link in the chat box. Till then, participant can fill that.
okay, the link you can share, save this. Pratik, sir, can you hear me?
Yes, sir.
Yeah. It's loading. Otherwise, you can share the videos to them. They can see later also.
Okay, fine. Just it is loading. Now just it's
Yeah.
completed. We will have within soon. Yeah.
Okay, 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 okay then. Okay then. Yeah. Yeah, Durgesh, some query has raised how to do the effect, such as if the car is moving, we are feeling jerks. Yeah. Moving, we are feeling jerks, acceleration and speed. Okay, of course, we'll try to address that, Durgesh. I think Mansoor Ali is talking about good presentation. Very good. Thank you. Uh, yeah. So your feedback link is ready right now?
Okay, so I hope our screen is visible all of you.
Yeah, once again you share, sir. Screen is not visible. Yeah.
Okay. Now is it visible?
Yeah, screen is visible. Yeah, go ahead. Go ahead, sir.
Okay, fine. Okay, fine. Now I'm playing the video.
Yeah.
Okay. Yeah, now I hope it is check all the steps properly and how exactly it is done. Visible, no, all of you?
Yeah, it's
Measure the
visible. Go ahead.
resistance,
Go ahead.
voltage and current through series and parallel
Okay.
connected networks using multimeter. Task 1. Resistances in series connection. Objectives. At the end of this exercise, you shall be able to instruments required. Regulated power supply 0 to 30 volts DC 2 ampere. Voltmeter. Suitable voltage 0 to 20 volts. Ammeter. Suitable current range 0 to 100 milliampere. Breadboard. Connecting wires as per requirement. Step 1. Take breadboard. Step 2. Connect potentiometer 1 and potentiometer 2 in series as per circuit
See, you
diagram.
can see the circuit diagram and accordingly do the connection. So potentiometer is connected, which is a variable resistor.
Step 3. Connect digital multimeter as ammeter in series with potentiometer 1. Step 4. Connect DC regulated power supply as per the circuit diagram.
I
Step
hope all of you
5.
steps
Switch
are
on the
audible
DC
also, na?
supply.
Yeah.
Okay.
Step 6. Record voltage across voltmeter V1 and V2 and current across the ammeter. Step 7. Vary the potentiometer. Step 8. Again record voltage across voltmeter V1 and V2 and current across ammeter. Step 9. Now, calculate equivalent resistance. Step 10. Switch off the supply. Task 2. Resistances in parallel connection. Step 1. Take breadboard. Step 2. Connect potentiometer 1 and potentiometer 2 in parallel as per circuit diagram. Step 3. Connect digital multimeter as ammeter in series with potentiometer 1. Step 4. Connect DC regulated power supply as per the circuit diagram. Step 5. Switch on the DC supply. Step 6. Record voltage across voltmeter V1 and V2 and current across the ammeter. Step 7. Vary the potentiometer. Step 8. Again record voltage across voltmeter V1 and V2 and current across ammeter. Step 9. Now, calculate equivalent resistance. Step 10. Switch off the supply.
Okay, so I hope everybody understood
Yeah, I
this.
think
This is
this is
just
a
one of
yeah,
the.
yeah.
Okay, so it was very good, and students are also enjoying all the practicals in virtual and augmented reality. So students are not exactly, we are having in a lab all the instruments. Breadboard is there, resistance is there, power supply is there. So they are doing on actual physical offline mode also, and virtual also. Students can have using Oculus and everything. They can do all these practicals. So students are enjoying a lot as a beyond syllabus practicals. All right, all of you. Now another practical I am going to show you right now, which is available for digital technique. You might be knowing there are various different types of gates. You have a AND gate, OR gate, and you have a truth table for that. Whenever there are two inputs, total there are four possible combinations, right? So now I'm going to show you another video that is verify the truth table of all logic gates. You have a AND gate, OR gate. So we have a digital trainer kit, and everything on left hand side there is all our inputs, on the right hand side there are all outputs. And let's have a look, you will enjoy a lot. Just give me a second, I'll share the screen now, and kindly give me the acknowledgement once the video is audible and visible also. All right, just 1 second. So I hope screen is being shared.
Not it, not it.
Okay, loading. Now I hope it is audible and visible also.
Task
Yeah,
1.
yeah.
Construction of an gate using IC 7408 and verification of truth table. Objectives. At the end of this exercise, you shall be able to construct and, or, not, NAND, NOR and XOR gates using X. Verify truth tables of AND, or, not, NAND, NOR and XOR gates. Components required. Connecting wires. IC, integrated circuit, Digital Trainer Kit. Step 1. Take Digital Trainer Kit.
So you can see digital trainer kit is taken.
Step 2. Connect Trainer Kit to AC power supply.
So trainer kit is connected to power supply.
Step 3. Insert IC in IC socket.
IC stands for integrated circuit. If it is a 14-pin IC,
Step
7 pins
4.
on one
Connect
side, 7 pins
VCC
on
to
other
pin
side.
14 and GND to pin 7 of Trainer Kit. Step 5. Connect logic input to pin 1 and pin 2. Step 6. Connect logic indicator output to pin 3. Step 7. Switch on AC power supply and kit. Step 8. Apply 00 as input.
So both the inputs are 0, 0.
Step 9. Observe
Check the
output and
output on right
record
hand side.
reading in observation table. Step 10.
So you
Apply
can
0,
see
1
LED
as
is not
input.
glowing. That means output is 0. Now give the combination as 0, 1.
Step 11. Observe output and record reading in observation table. Step 12. Apply
So
1
again output
0
is
as
0. Now give
input.
the combination 1, 0.
Step 13. Observe output and record reading in observation table. Step 14. Apply 1 1 as input. Step 15. Observe output and record reading in observation table.
Now you can see LED is glow on. Red color is status. So output is 1.
Step 16. Switch off AC power supply and kit.
I think we can share all these videos. Very interesting and good. They can see later also.
Yeah, sure, sir.
Yeah.
Yeah.
If
Task
possible,
2.
you can share those
Construction
videos
of
to
NAND
participants
gate
also.
using IC 7400 and verification of truth table. Step 1. Take digital trainer kit. Step 2. Connect trainer kit to AC power supply. Step 3. Insert IC in IC socket. Step 4. Connect VCC to pin 14 and GND to pin 7 of trainer kit.
So pin number 14 is connected to
Yeah.
VCC and pin number 7
This
is connected
entire
to ground.
explained procedure they have given. Yeah, very good.
Yeah.
Yeah.
Step 5. Connect logic input to pin 1 and pin 2. Step 6. Connect logic indicator
I think
output
those who
to
are
pin 3.
especially from electronics background, they can understand well. Those who are having other background, they may have some, but sir's objective is to show how AI/ML is
Step
used
7.
for
Switch on AC
AR/VR.
power supply and kit.
Correct.
Yeah.
But computer IT students also, they are having
Yeah.
all those topologies, right? Star
Yeah, yeah,
topology, mesh topology. So those
yeah.
practicals
Step
also can
8
be done
apply
using
0,
ARPM,
0 as
and
Yeah,
that I
yeah,
have
input.
that can be.
implemented.
Means practicals can be done through AR by use of our AI/ML IoT. Yeah, it's very
Step
interesting.
Yes,
9
Yeah,
observe
correct. Yeah.
output and
yeah.
record reading in observation table. Step 10 apply 0, 1 as input. Step 11 observe output and record reading in observation table. Step 12 apply 1, 0 as input.
Yeah. Some are
Step
from mechanical
13
background, so
observe
they may not be
output and
able to
record reading in
follow.
observation table.
Yeah.
Step 14 apply 1, 1 as input. Step 15 observe output and record reading in observation table. Step 16 switch off AC power supply and kit. Task 3.
All
Construction of NOT
the
gate using
electronics
IC
background experiments are there with you, sir.
7404 and verification of truth
Pratik,
table.
sir.
Yes, sir.
All digital
Step
lab experiments
1
are there.
take digital trainer
Yeah.
Okay.
kit.
I think they understood your concept, what you are trying to underline. I think. Yeah.
Step 2 connect trainer kit to AC power supply.
Now, basically, mechanical students also have subject of digital
Step
electronics.
3
So
insert
NOT gate is
IC
something
in
like when the
IC
input is
socket.
0, output is 1. So now
Mm.
check the scenario. And when the input is 1, output is 0. That is the truth table of NOT
Step
gate.
4
Yeah.
connect
Logic
VCC to
gates
pin
can be. Yeah.
14
Yeah.
and GND to pin 7 of trainer kit. Step 5 connect logic input to pin 1. Step 6 connect logic indicator output to pin 2. Step 7 switch on AC power supply and kit. Step 8 apply 0 as input.
Now, when input is 0, output should be 1. So let's check the LED status.
Step 9 observe output and record reading in observation table.
So output will be 1.
Step
Yeah.
10 apply 1 as input.
So now input is 1, so output will be 0. That
Step
means red
11
light will
observe
not glow. See,
output and
LED is not
record reading
glowing.
in observation table.
Output is 0.
Step 12 switch off AC power supply and kit. Task 4 construction of XOR gate using IC 7486 and verification of
Chapters
truth table.
properly harness.
Step 1 take digital trainer kit. Step 2 connect trainer kit to AC power supply. Step 3 insert IC in IC socket. Step 4 connect VCC to pin 14 and GND to pin 7 of trainer kit. Step 5 connect logic input to pin 1 and pin 2. Step 6, connect logic indicator output to pin 3. Step 7, switch on AC power supply and kit. Step 8, apply 00 as input. Step 9, observe output and record reading in observation table. Step 10, apply 01 as input. Step 11, observe output and record reading in observation table. Step 12, apply 10 as input. Step 13, observe output and record reading in observation table. Step 14, apply 11 as input.
Each students.
Yeah, you
Step
can share
15,
those
observe
videos, whatever you
output
want
and
to share
record
later.
reading in observation table.
Possible.
Yes,
Okay.
sir. Yes, sir.
Yeah. You can proceed
Step
next. If you
16,
want to say
switch off
something, sir,
AC
again.
power supply and kit.
Okay, fine.
Yeah.
So this is all about augmented reality and virtual reality. Now, if any of the students are from mechanical background or let's say instrumentation, and
We-
if you are having list of practicals, those practicals also we can do it using AR VR. So just list of practicals is required from mechanical background also, and we can develop all these practicals. So thank you so much. That's it for today's session as far as AR VR is concerned, which is integrated with AI ML and IoT. Thank you so
Yeah.
much.
I'm very much thankful to you, Pratik sir. With short notice, beautifully you have kept the subject augmented reality and virtual reality, one of the important application of the artificial intelligence, the machine learning, and the through IoT. I think we are very much thankful. Over to Sai.
Yes, sir. So once again, a very formal thank you on behalf of IETE Pune chapter, Buds Engineering Academy, and Civic Incubation Center. Thank you, Pratik sir, for this enlightening session. I think we have really understood practically the applications of augmented reality and virtual reality, and
Okay.
it has really simplified all the practical applications. So thank you so much, sir, for being here
Yeah.
with us.
Yeah. Just we'll extend some 10-15 minutes are there. So we'll extend little bit what the Pratik sir has underlined. The same thing we'll extend how this is designed, the programmatically also. Yeah, Pratik sir is getting thank you from Vijay also, Durgesh also. Yeah, Pratik sir, chat box people are saying thank you. So yeah. So just I will share my screen further for some time.
Yes, sir.
Yeah, yeah, yeah. So Pratik sir has already given good information about augmented reality and the virtual reality. Before proceeding, the same thing what sir has briefed here. I think just I will add only one thing. The Bahubali movie, most of the participants they may have. So Bahubali movie, I think it's most of the shooting is Ramoji Film City in Hyderabad, and they have heavily used the AR/VR as Pratik sir has underlined. So Pratik sir has already briefed about the application of how AR/VR is being used for our day-to-day experimentation in the college. For example, he has taken some digital lab and he has some brief of information. A lot of videos sir has. Some of the videos sir may share you with us. And with this, if you look for the actual implementation part, then just here you can see a little screen on here over here. So you can see, as sir has underlined, the brief, beautiful explanation about AR VR and how the application is being implemented. So you can see AR and VR are exciting technologies, sir has explained, and can bit complex to fully grasp. But you can see some simple programs are there to provide with the AR VR using OpenCV Python library. So participants are requested to take a note of when we go for the PyCharm, no, the PyCharm or the Python compiler. Then there is one library, that's what the OpenCV, the library, where we'll have some demonstration on ER VR again further. The OpenCV library is required for that, and for that OpenCV, if you go for the Python, then I think in the Python environment there will be some the NumPys, the pandas. So there you can import here CV2 library, the package. That's what the NumPys and pandas, as we have seen in the Python. So here this model, for example, as sir has created some 3D objects over here, as Pratik sir has underlined 3D objects. So for example, 3D objects like multimeter or CRO or any other mechanical object. For that purpose, in the Python, how the 3D model can be implemented, as sir has underlined here on the screen in this particular video. So for that purpose, in the Python, you can see line number 17, the CV2 imread. I am read the cube PNG CV2 imread. So that's what the function we have to use for example, we have to create this multimeter in 3D. Then in the Python environment or the OpenCV package, you can have a function required for us is a CV2 imread function. And this function line loads 3D cube model, and the name is cube PNG CV2. So this function is used to load the images in the this our AI, and the image is loaded with the alpha channel impact. So here I think you can understand what sir has shown in the video. So here CV2 imread is a function required to load the images, and then sir has added some camera also in it. So for that camera, the embedding for the camera, so there is one more model in the Python that you have to understand, that is a cap CV2 video capture. So there is one more function in the Python library in the OpenCV, that's what the CV2 video capture. This will initialize the webcam. So for example, multimeter is there and the real-time environment which we need to augment in it. Then for that we have to add the webcam, and the web capture class you can have a index 0, and then suppose camera is ready and 3D model is ready, and if it is a boolean true, if it is a true, then you can the framing will start, and that framing is cap.read function. So here function used is a cap.read function, and for example, suppose some face is to be embedded, as I underlined the Bahubali movie. The heavily they have used the AR VR, as Pratik sir has underlined. So here the one more function is required to generate this kind of the videos for us. That's one is required is a cap.read, and that loop captures video from the webcam in the iteration. So the model is being implemented, and then you can have the image through the webcam. So the webcam function is a cap read, and then moving to the further face detection. So for further face detection, you can have a suppose particular person's face is to be included in this particular model. Then in the Python library, we can have one more function that is a face cascade and CV2 cascade. Here this function is required, and then face cascade detect multi-scale environment. So the scale factor and the mean neighbor and the size. So that's what the function is required. And with this, here you can create a cascade classifier object, as sir has underlined in these particular videos, to make us understand how the laboratory experiments can be learned with the help of the ER and VR environment through our ER and ML through the remote environment. So here cascade classifier face detection, then we use this classifier to detect faces in the current video frame. So this is what the video and the face detection is there. Now this video, suppose if you want to move it for the 3 dimension, the x-axis, the y-axis, and the z-axis. So I think we can understand different the coordinate systems are required. We have a knowledge of we should have some knowledge of coordinate systems. So one of the coordinate system, that's what the X, Y, Z. So you might be aware of the some 3D objects, the 4D objects, 5D, and in case of robotics, we can go for 6D and 6 degree of also. So this is what the X, Y, Z, and one more they have given, and the size also you can have a function using the CV2 resize, and then you can add that the object which we have taken, the for example multimeter, and for example the real-time environment, the webcam. So that can be added with the help of the overlay function, and that function is there is a overlay YH function. And in the loop you can see the each detected face we recognize loaded cube image match size detect face, like that what exactly the video camera is being augmented over in the 3D objects over here. Similarly, there is a in the OpenCV environment there is a one more function we need to understand. That's what the CV2 IMShow function. So in IMShow function you can have a AR example and the frame. So IMShow function, so augmented reality, which we are learning right now in this environment, and then we can have a one more function. So basically this code displays a modified video frame with the overlaid cube using the CV2 IMShow, and this loop continue until the user presses the Q key, which breaks the loop and ends the program. Similarly, for that, one more function under the heading of Python, again, you can have a destroy all index function. So same thing, the sir has shown some videos, the augmented realities and the virtual reality. And this is what the steps, I think we can understand which kind of functions are required and where we can create this kind of AR environment as the Bahubali. Of course, it's a very high-end technology, and the different technologies they have inbuilt multiple, but as this beginning to understand what exactly the augmented realities and virtual realities in the AI/ML IoT environment. So if you look at here again, the same thing which I have shown earlier, the replete compiler. I think at the beginning itself I have explained you what the replete compiler, and with this replete compiler, the libraries you can import, one is a CV2 which we have underlined right now, and the NumPy as a NP library. So these are the two things we need to import in the replete. You can try it later. Of course, I can show you the code also where you can create your own AR/VR environment. But this what it is a beginning for our further learning in the AI/ML in the AR/VR environment. Now you can see here, for example, 3D, just like sir has shown some multimeter over here, or some CRO here, or some IC. What is the 3D model? So for that purpose, the library here you can see load 3D cube model. So for load 3D cube model, you can use the cube CV2, and for example, this image means if you want to inbuilt, for example, the multimeter, or for example the IC. So that image of the multimeter or the image of that particular IC or image of that particular breadboard, you can put it here. So function which is a 3D, and suppose if you want to add image of the multimeter or the voltmeter or the CRO, so that image you can put it here at the line number 5. I hope this might be understandable. You, of course, at the end we'll take some questions also. Pratik sir is also there. He will also take your questions if necessary. You can put it in the chat box meantime as time is running to close. But here you can create a 3D cube models, and this is the function required in the Python. In the PyCharm, we can have a portable PyCharm or you can have a replete online compiler where a lot of libraries can be automatically, you can install automatically with this environment. So here is a 3D, and here if you want to change that image, then there is a one function, that's what is called as a imbreed function, and which is a unchanged function. And as I told you, first of all, the 3D model is to be implemented. Then further you can have a webcam. So you can connect some images from the webcam. So if you want to connect the webcam, then you can have a function, that's what the video capture function. So with the help of video capture function, you can load the webcam. So what the 3D object and the real environment. So the one is a augmented environment, or you can call it as a virtual environment. That's what the multimeter or the keyboard, which we have seen in the videos. And then you can add a camera. That's what the video capture camera. That's called as a load webcam. You can have. And suppose if it is again it's a Boolean one. So there is a, while it is a true, Boolean means the camera is present and the 3D object is present. Then you can read it. So with the help of read function, so line number 11, you can see it's a cap read function. So the cap read function, frame read function is used for here. And if things are moving further, just like a calculator, you can put the addition and then break in the Python or C programming or the Java programming environment. Then you can have a break. Means this much information, the 3D model and the webcam is added, and it will be stable. So you will find in the video it is stable for some time. And if you want to move, for example, further, suppose if you want to detect somebody's face in the 3D environment over here with the help of AR and VR in the 3D environment, then you can have one more the function. As I explained you, two function. One is a 3D function and one is a webcam addition function. And moving to further, the detect the frames from the face. Suppose face is somebody's real. Suppose teacher is guiding that particular experiment, how the logic gates, the OR gate, AND gates are being learned. Suppose teacher is, suppose as in the video you have shown, you have seen that the teacher is putting some hand with the multimeter. The two probes of the multimeter is to be connected to measure the voltage. For example, that particular environment, suppose that environment is to be included in this particular environment, then you can have a one more the phase frame. That's what the phase cascade. And with phase cascade, you can have a CV2 dot cascade classifier function. And with that cascade classifier function, you can have a addition of the real phase. So as I told you, the two things, one is what the 3D model is being implemented in the AR/VR through the AI/ML environment, and then further the webcam is being included. And further, suppose some teacher want to explain that particular experiment to his students, then you can have one more function. That's what the phase function. And again, the probes, you can have a 3D model. Then you can have a Cartesian environment, Cartesian coordinate system. Then you know that the polar coordinate systems and so on. So the geometrical systems where the X, Y, Z. And suppose if you want to resize that particular image over here, then you can have again a resize cube with the help of CV2 resize function. And again, for example, overlay the cube on the face, then the NP, the copy frame function will be there. That's what the overlay function, np dot copy frame. And then you can CV2 and add weighted function. And with the help of then, for example, as Pratik sir has underlined the AR frame example, so you can put it, suppose for example, sir has taken example, for example, here the experiment of the logic gates, for example. So that example of that, you can put it here as a AR example in this particular frame. And then the wait keys, I think you might be aware of the wait keys. You have to wait for some time to get it, extract that image of that particular example. And with the help of wait keys, again, it is a break. Just like addition, subtraction, we can put the addition and it can break, subtraction and break. Like that, the AR example is taken and the break. And then at the end, suppose if you want to save it, you can have a save with the help of release again. Or if you want to delete it, the experimentation, then you can have a destroy all windows function. I hope it might be understood to you participants. I hope today's session you might be aware how AI/ML is used for the AR/VR is one of the application. As we have seen, AI basically it's a technology in the different technological is added, but it's one of the case studies as Pratik sir has bring in front of us. So here, this is what the small demonstration for that, as time is running, but those who are interested, they can proceed further. This course also, again, I will put it for you. But meantime, if you have any queries, we may take your queries, participants, if you have any queries. So is it possible to unmute? Yeah. Yeah. Just, you can.
Now participants can access their microphone.
Yeah, you can active if you want to have a queries. You can get it your queries clarified as Pratik sir is on the here dais, and we will try to explain you the if queries if you have. It might be general queries or it might be what we have discussed here. I'll give 1 minute of time. Yeah, Kalpana, if it is possible, run this code. Okay. Okay. Any other thing? Yeah. So to run this code, as of now, here you can see this is a replit. This code I will give you it here. So for that, to run this code, we'll try, but here again, camera is to be included. The image is required. Suppose, for example, image of we are taking. Suppose the image required is, for example, this multimeter image. So we need to connect we should have a image which we are going to do it. So you can try as a project. We may be able to guide you. Don't worry. I will give you the code. So you can have a multimeter image ready with your system. Then you can have a port connected with the webcam, and you can have a setup to do it. But here in the Python, you can see, for example, here is a run. You can see there is a run. Then some of the libraries, the traceback here, you can have a different module. You can have a file. You can have a CV2. We can have a OpenCV, that library. So its setup is required to run this. The entire setup is required. Just we are trying to understand as of now the how we are and what are the different functions required and where to execute that code. So if you are from the if you are taking it for the project for your college to design AR/VR through AI/ML technology, then you can proceed it. This code I will paste you for. Okay. So to run this, we need a real-time camera environment. We need a 3D images. We need a setup for that. So it may not be to install the library. So in real time, it may not be possible for us right now. But if you take as a project, then it's possible. Okay, very good, Kalpana. Anyone want to know something? Yes. If you have any queries, put it in the chat box, or you can unmute yourself. Otherwise, we have to close. If you have any question with the Pratik sir also, he is there. He will take questions. Vijaya, Durgesh, Kalpana, Dr. Nitin. Okay. Okay. Once again, thank you, Pratik sir. Over to Sai.
Yes,
Let's
sir.
close it.
Thank
Yeah.
you so much, Pratik sir. Summarizing today's session, in the first session, we have seen the application of EV as for artificial intelligence, and in the second session, we have also seen AR, VR, augmented reality, and virtual reality as application of artificial intelligence, and we have also executed a few Python codes. So, with this note, let's conclude today's session. Participants are requested to join by 5:45 p.m. for tomorrow's session as well. If you have any doubts, you can contact us and put it in the chat box, or you can put it on WhatsApp. So, with this note, I will end the session. Will that be fine, sir?
Yeah. And participant must remember that 80% attendance is required to get the IET certification from New Delhi, that certification. So you need to attempt the quizzes also. Okay, thank you. Thank you.
Sir, so should I end the session?
I think no further queries. You can end now. Yeah.
Okay. Thank you so much, everyone.